negative exponent. And from our notes on Friday, what would you tell me is the key thing that a negative exponent does? What is the key word? Because we know if we have something, anything to the 0 power, right, it always equals 1. And the reason that that works, remember, is that in the video you had like 3 to the third was 27, and 3 to the second was 9, and 3 to the first was 3. And if you're going down, what are we actually doing each time? Dividing. So I'm dividing by 3. 27 by 3 is 9. This is going to be 3, so this comes out to be 1. And when we had 3 to the negative 1, that became, dividing by 3, 1/3. And these two numbers are what is the word? Got it, Alexis? They are reciprocal. So the key thing with negative exponents is we are talking about reciprocal, right? Reciprocal. So if I would have gone to 3 to the negative 2, I look at 3 to the second, which is 9. It is 1/9. So that was your notes that we were looking at Friday. Okay. As you looked at the problems over here, any ones that you would like for me to take a look at? For example, as I'm looking at people's papers, so if you have yours out, please have those out. And if you're going to do yours today, what I might have you do is you just think you left yours. You could do it in here, but we could just write this on a piece of paper. Okay. So if I'm looking at yours, there's a lot of people that for this first one here had negative 25. It is not negative 25, right? Because this is over 1, and this is the reciprocal of 5 to the second. And 5 to the second is 25, and this should be 1/25. Any questions that I could answer on here? The one that has come up the most in most of the classes was number 15. And here was what the problem was. It's really 5. What power is 5 to if there's nothing there? 1 or 0? 1. And then you have this x to the negative 4. So this is really what that problem looks like. 5 over 1 times x to the negative 4. And what I had for a lot of people, their answer was 1 over 5x to the 4th. And that's not right. The reason it's not right is we can't move the 5 down, right? We're just moving the x. Hey, Jack. I wondered, where did you think football is today? Tomorrow. Yes. I was thinking, I should have seen you here. It's good to have you. So I have 5 over x to the 4th, right? Because the 5 was a positive exponent, and the only thing that was negative was here, and so that gets moved down. When you're looking at this type of a problem, it means reciprocal of what was inside, right? So find the reciprocal of that, okay? By the way, not only did the sub have good reports, but Mrs. Law did also. So thank you very much for helping my sub end her day on a high note instead of being angry and not happy. The tests, I just finished this morning. The last few people finished coming in and getting their tests done. I think I have one person who's absent that hasn't finished theirs, but we will get them all back tomorrow. So I should have them in the grade book a little later, either tonight or tomorrow. It just depends on how busy. But I got most of them corrected, and overall, those of you that explained how you came up with the theorem did a pretty good job, and with the rest of it. So hopefully I will get those up tomorrow. So this is just kind of review. 0 and negative exponents. The 0 exponent, anytime we have a 0 exponent, the key thing is with 0 exponent, it's going to be equal to 1. And I had a couple people in my last period class that kept going, 0, 0, and then halfway through the class, I finally like, oh yeah, that to the 0 power is 1. And again, where does that come from, being to the first power? It's kind of like when we looked at the notes from Friday, where you were looking at that group of numbers and how this number always comes out, if you're looking at that pattern, that comes out to equal 1. The second part is that negative exponent. Anytime you have a negative exponent, the key word is reciprocal. so that when you look at this, if it's in the numerator, you're moving it to the denominator to make it positive. If it's in the denominator, you're moving it up to the numerator. And today in the videos that you watch, it kind of talks about the stairs, or looking at, and the key unlocks the stairs and putting it that way. So it's just another way of thinking about it, okay? So, second page, that bottom page of your notes, we're going to watch this video, and you're going to get the answer where they talk about if you have a negative base to an even power and a negative base to an odd power. So this is on that bottom page of the notes. And then you're going to get these three answers also as you watch the video. So we'll take a look at those.
After today's lesson, we will be able to apply exponents to negative bases. You already know that an exponent represents repeated multiplication, and that the exponent, or power, A, will tell you how many times to write the base, B, in a multiplication sentence. But what happens if we have a negative base? First, we need to be able to recognize when we are given a negative base. To truly have a negative base, you must have the negative sign inside parentheses with your base, such as we have here on the left. If you see a negative sign to the left of the base, but your base is not in parentheses, your base actually is a positive base. The negative sign indicates that after we have applied the exponent, we are to multiply our result times negative 1. If you think about a negative in front of the base this way, and recognize that the order of operations says exponents come before multiplication, you remember to raise b to the power of a first, then multiply it by negative 1. Let's look at two examples with numbers here. The first example, negative 3 is clearly your base. When you square it, you're going to multiply negative 3 times negative 3. That gives us a result of positive 9. In the one here, 3 is actually the base. We have a base 3 that we are going to multiply times itself twice. Once we get our result, we will multiply that times negative 1. 3 times 3 is 9, times negative 1 equals negative 9. Two expressions with very similar starting turn out with very different answers. This is one of the most common mistakes math students make.
So when I look at this, this is one that often I have students that get wrong. And it's just this understanding of what you are squaring. So keep in mind that this negative is just like a negative 1, like they are talking about here. I still have students in our algebra class that still keep getting that wrong as we are looking at it.
In parentheses with the base, as they should. And write it instead like the second example. If you write it in your calculator as negative 3 to the second without putting it in parentheses, it's going to assume the base is positive 3, then multiply the result by negative 1 and get this answer of negative 9 here. So be very, very careful when you are working with problems that appear to have a negative base. Let's explore this further. You already saw that negative 3 to the power of 2 was positive 9. What about negative 3 to the first? Negative 3 to the first means we only write negative 3 once in a multiplication sentence. We get negative 3. What about negative 3 to the third? We'll write it 3 times in a multiplication sentence. We end up getting negative 27. Negative 3 to the fourth, we positive 81. Are you starting to see a pattern with the type of exponent that leads to negative answers and the type of exponent that leads to positive answers? If you don't quite see it yet, check it out here where I use ones. Ones are much more easier to multiply when I get up to bigger exponents. See that for every other exponent, we're getting a positive 1, and every other exponent we're getting a negative 1. Notice all the negative ones occur when we have odd exponents. 1, 3, 5, and 7. Whereas all the positive results
this is where we're going to fill in your notes coming up.
2, 4, 6, 8. Why is that? Can you see that when I have an even exponent like 2, these two negatives pair up and multiply to be positive 1. Even when I go all the way down to 8, these two pair up, these two pair up, these two pair up, and these two pair up. So the end result is me multiplying a bunch of positive 1s times each other and getting positive 1. What leads to a negative 1 is when we have, after pairing up these two, we end up with this one that doesn't have a partner, and therefore this positive 1 is multiplied by a negative 1, and we get a result of negative 1. You can even see that down here on the exponent of 7. Pair up, pair up, pair up. There's 3 positive 1s multiplied times each other. Then there's one sad negative 1 here with no partner that turns the whole thing negative. The same concept works with any negative base. Any negative base to an even exponent, the negatives will pair up and result in a positive answer. Any negative base to an odd exponent, there'll always be that one lonely negative number in the multiplication sentence that turns the whole thing negative. Let's use this idea to check out a few practice problems. Negative 1 to the power of 15. Man, I don't want to write out all those negative ones. Well, good news, you don't have to, because you know that as I keep multiplying 1 times itself over and over again, I'm just going to keep getting 1. And since I have an odd exponent, but I got one lonely negative 1 left, my answer is just negative 1. Here I have...
Did everyone write that one down from your notes? You got filled in that both positive and negative on the bottom part, and now you put in that first one was negative 1, so now they're going to look at this one. And it's, I know he talks a little fast too, but just kind of take a look at how he's solving this and think about it. Oh, sorry. You should have those positive and negative. There we go.
And so I get negative 4 times negative 4. That's equal to positive 16, right? I hope you did not fall in that trap. That's not correct. The base is actually positive 4. So I'm going to square positive 4. I'm going to get 16, but the negative sign comes and just sits out front, so I get negative 16. I hope you didn't fall in that trap. Here my base is negative 10. I'm going to multiply it times itself 3 times. Negative 10 times negative 10 is 100 times negative 10. And I get a negative number as I would expect, negative 1,000. So now you can apply exponents to negative bases.
So, as you were looking at this part, we had, the first one was positive, right? The second one's negative. It makes a huge difference if you have a parenthesis or not. The first one here and the last one here were negative because of the parenthesis. The second one, even though it's an even power, because there's no parenthesis, our answer is going to be negative and not positive. So that's kind of where people make those most common mistakes, I'd like to say, as they look at that. This is the page. When we go through this page is what you want to have open when you do your homework. Because both this page and then the part below it are the types of problems that you're going to see in your homework. And this is what you want to be able to look at as we're doing it. So we're not going to watch this whole video. We're only going to watch a little part of it. But as you take a look at this, this kind of explains a little with that negative exponents with the stairs and looking at it that way. So,
what is the value of 1 divided by 5 to the negative third?
What's your guess? In this lesson, you will learn how to simplify expressions involving negative exponents by applying exponent rules you already know. Remember, any base raised to the exponent of 0 is 1, and any base raised to a negative exponent is equal to 1 divided by that base raised to the opposite or positive exponent. Also, to divide a fraction, a over b, by a fraction c over d, you would multiply a over b by the reciprocal of c over d, which would be d over c. Back to our original question. What is the value of 1 divided by 5 to the negative third? Since the negative exponent indicates our base will move to the denominator with a positive exponent, we now have 1 over 5 to the positive third. Yeah, by imagining the numerator.
Sorry.
1 over 5 to the positive third.
This is ugly, right? Yeah. We don't want to go through this, so we're going to use these rules that apply that we know about that word reciprocal. So you're going to see he's explaining it, and he's explaining it in terms of dividing fractions, okay? I'm not sure why I keep... Okay. Nope. Let's get through
since we multiply by the reciprocal. So we have 1 times 5 to the third over 1. This results in 5 to the third.
So
we've answered a question.
Step, right?
1 over 5 to the negative third power is equal to 5 to the third power. We could also look at this as 5 to the third power over a denominator of 1. This will help us in our next step. So when we see 5 to the negative third in the denominator, it results in 5 to the positive third in the numerator. And when we see 5 to the negative third in the numerator, it results in 5 to the positive third in the denominator, with a 1 in the numerator. Here I want to illustrate a way to remember this idea by imagining the numerator and the denominator of a fraction as 2 levels of a building, with a locked staircase in between. If we start with a base raised to a negative exponent in the numerator, we can look at the negative exponent like a key to the locked staircase. The base uses the key to travel downstairs and is now in the denominator. It's very important that the base leaves the key in the door, so that when it arrives in the denominator, it no longer has a key. It no longer has a negative exponent. It's also important to realize that since the base is now in the denominator and there is nothing in the numerator, we have to leave a 1 there to indicate we are dividing by b to the power
So
of
this
a.
kind of key thing is what
So
we're
let's
going
look
to
at
be
this
talking
when
about.
the base starts, the base with the negative exponent starts in the denominator. Again, the negative exponent serves as a key for the base to unlock the staircase and travel up. The base leaves the key in the door, so it no longer has a negative exponent once it arrives in the numerator. Now there's nothing, so it no longer has a key there. Now that there's nothing in the denominator, we can put a 1 there, but since that indicates we are dividing by 1, and dividing by 1 will not change anything, we do not have to put the 1 there. So let's try a few examples. This example asks us to simplify 2 to the third.
So we are not going to do this. This one gets really complicated and really ugly. And I think if we are looking at our problems that we are doing, it's going to make a little more sense to you. So as we work through these, one of the first things I want you to think about is we are going to put every one that is not a fraction, we're going to always write it as a fraction over 1. So that first one and the middle one, we're going to write those as fractions over 1. Same thing when you do your homework. If you don't have a fraction, put it over 1. Next thing is we have a negative exponent. So if we're going to make the negative exponent positive, it's in the numerator. To make it positive, we're going to rewrite that as a reciprocal. So 1 over x to the 9th, done. That's my answer. Your goal as we finish this unit is not to have any negative exponents. Write this with us as you're doing, okay? So this next one, it has 1 over n to the negative 3. N is to the negative 3 is in our denominator, okay? So we want to rewrite it, and we're going to rewrite this one and make sure that these are exponents. So if I see something like this, to me, that's not an exponent. That is not x to the 9th. So you got to make sure you're making a little, and if you need to make your variables bigger, so like if you need to put n to the 3rd over 1, or you just put n to the 3rd, but I need to be able to tell that it's an exponent, that it's the smaller number there, okay? This problem, we're going to rewrite it. I want you to put it as 4 over 1 times c to the negative 3 over 1 times b over 1. Now, this is kind of like that question 15 in your homework today. What is the only negative exponent that we really have to move if we are looking at this one, Sophia? What's my negative exponent that has to be moved? Is 4 have a negative exponent? No, it's actually a 1, right? And b is actually a 1. This negative 3 one. This is the one that has to move. So when I look at my answer, I'm going to have the 4 staying in the numerator. I'm going to have the b in the numerator. C is going to move down here, and it's going to be to the 3rd. And that's my answer for that one. Right? So, well, especially like on the test sometimes, do you have to show the work? I would be okay for some of you going right to this, but if you move the wrong thing, sometimes I think writing it out like this is helpful. I know, this is tough. This is really hard Algebra 1 stuff. This is, like, used to be taught Chapter 7 of Algebra 1. It's now an 8th grade standard. It's hard, I get that. So just know, I'm not going to, like, expect right away that you get it. But we got to work on it, and you guys can do this, okay? So we're going to look at this one. Let's kind of rewrite it the same way we did here with the 1. So we're going to think about this as 2 over 1 times 1 over a to the negative 3. This is my negative exponent that I have to move, right? The 2 stays. So I'm going to keep the 2 in the numerator. And this a to the negative 3 is going to move from the denominator to the numerator, and it's a to the 3rd. And I still have this 1 down here, so I could keep that. And someone said, well, can I just write an answer of 2a to the 3rd power? Yep, that's the same thing. If you ever leave it over 1, I will not mark that wrong. okay? A lot of people like to have it over 1 instead of not putting that. Are you with us? You still writing? Okay, good. Did you go back and write this one? Yeah, go back to this one too. All right, so that last one, let's write it out first as n to the -5 over 1 times 1 over m to the second. The people that you're sitting next to or beside or behind, tell them, this is the one I think we should move and this is what it looks like. Do that right now.
This is the one I think we should move.
This one's out. Okay, you can talk with these guys. Jack, you ready? You guys discuss?
We thought we should move the n to the -5.
And to the -5. Okay? So if we move it, what's it going to look like? So I'm going to have n to the -5, but now it's going to be +5, right? And I'm keeping the m down there too.
Yeah.
Does it matter if I would have had m to the second and then n to the 5? Does that order matter? Are these the same answer? These are the same answers. Did every group kind of agree that that was the one we were moving? Okay. So we're always moving our negative. And I think sometimes it's really helpful to separate them because or else it's really easy to move like the wrong thing. Like some people think they had to move both of these and switch places. Only move negative exponents. The goal as we get ready for this test, and on Friday of this week, we have this exponent quiz. It's a pretty major quiz. It seems to be almost harder than the test because the test is exponents and scientific notation, and the quiz on Friday is just like super intense with all these multiplying and dividing and negatives and zeros and all of this, and they get ugly, okay? So this is this next one, right? If we were going to show our work, again, I might write it as 3 to the -2 over 1 times 1 over n. If you were going to tell me what to circle, Mara, what would you say? Which one's going to be changing or moving? The first one. So this is my one that I'm moving. So I know the n is staying in my denominator. And I'm now going to move the 3 down also. It's 3 to the second. Was a -2. It becomes positive. And I have a 1. Now 3 to the second we know from memorizing was 9. 1 over. And I'll have some people get this answer, and I'll just like shudder because when I have to correct it, they'll say, oh, that's equal to 9n. Is 1 over 9n the same as 9n? No. So, you know, I just like, oh, I have to take off a point then, right? Because you misunderstood how to answer the question, okay? So, try this next one. I'm going to have you write it out. I want you guys to try these on your own. Try and get your answer. If you think you need to have it written out like this to show your work, that might help you to circle what's going to move. Put your answer. If it helps you with the next one, by all means, kind of check with your shoulder partner. I'm going to call on you in just a minute. They were looking at their thinks they've got this and want to share. Because I'll go through it. But if anyone thinks they got it and want to, Alexis, want to get the first one to try?
Take the x to the -2, put that on the bottom.
It's going to go to the bottom. Is that the only thing that's moving? So I'm going to keep the 3. I'm going to leave the y they were where they were. I'm going to put the x to the second. It was a negative exponent, so it's on the top. It has to move down, so I have all positives. Okay? Brooke and Faith, you guys want to give this one a try down here? Which ones would you circle that you want to tell me to move?
A to the -1st power.
These are my 2 that I'm moving, right? What do I know anything to the 0 power is? 1. So this is just like 1 times 1, 1, 1, right? So we know we can have 1 on the bottom. But you just said we circled those 2, so we got to move the a down. And if you like putting a to the 1, write a to the 1, right? And c to the 3. If you don't want to put a 1 here, it's understood mathematically that there's a 1, okay? I won't mark it wrong if you go from a -1 to a 1, okay? And then as we are looking at this, the 6 needs to stay up on top. Well, we said this was equal to 1, so 1 times A and C is still going to be A and C, right? So this is our answer, 6 over A C to the third. What if you had 6 C and A, C to the third and A? As long as C has the exponent 3 and A has the 1, it doesn't matter the order, okay? All right, how about the last one? Anyone want to give it a shot? I'm going to need another group. Mike, you guys want to give?
So we said that you're going to bring the 2 to the negative third power down,
Okay.
and then you're going to bring Z to the negative 7 down,
So I'm going to put 2 to what power down here? 2 to 3.
and then Z to the 7. And then on the top you'll have X to the 7.
And I think what happens when you circle it, at least it lets you know, and even if you circle it, not even put an arrow, I don't know, something like that as you're doing your work, because they get really ugly when we get towards the end of this. And I mean, if you just page back in your homework and you look at some of those, then I know that this stays put. And my final answer, if I'm looking at that, x to the second over 8 and z to the 7th is what you're going to be looking at. Okay? Now, I agree, these are hard. You need to break it down and you need to think about it. You guys can do this, okay? So, the other thing is I don't know if any of you have ever seen on your calculators that -1 button. On your calculators, that x to the -1. Sometimes it says x to the -1. Do you know what that does to a number? What did we say negative exponents do?
Make it positive.
No, it doesn't. What do negative exponents do? They make this reciprocal. So if you put in 2 and then you hit this button on your calculator, it gives you a half. It gives you 0.5, right? And if you put in 0.5 and you hit this button, it's going to give you 2 because the reciprocal of 0.5 is 2. That button on your calculator is the reciprocal. So that's why that negative exponent, it does mean reciprocal, okay? So I just wanted to make sure. Sometimes people are like, why is that button on it, okay? We're going to finish our notes. We got just a little to go. You awake? Do we need to stand up at all in this class? Last class we had to stand up.
Yeah, let's
You need to stand up? All right.
Population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria can be modeled by the expression below, where H is the number of hours after scientists measured the population size. 1,000 times 2H. Evaluate the expression for the given values below and explain what each represents in the situation.
So it's going to say evaluate and explain. You have one homework question that looks like this. All the rest are like that page before in your notes. So when we look at this and it says evaluate first, when H equals 2, that means on your paper what I need to see is 1,000 times 2 to the second power. And you know 2 to the second is 4, and 4 times 1,000 is going to give us 4,000. So my answer would be, this is the evaluate, 4,000, right? That's what it was equal to. Then it says explain, what does it mean in this situation? That means that there are 4,000 what? Bacteria, right? The doubling, that was this 2 in our equation. H was in ours. 4,000 bacteria when?
In 2 hours.
2 hours after the experiment started, right? After this lab condition, right? So after the experiment started. The next one says H to the 0. And if I'm looking at H to the 0, I'm going to have 1,000 times 2 to the what? Hours is 0. H is 0. Going back to this equation. So H to the, we're going to put it 0. But that's actually, I agree, 1,000 times 1, which is 1,000. And it says, that's our evaluate. What does it mean in this situation? It means that we had 1,000 what? Bacteria at what? Bacteria
In 0 hours after doing the experiment.
in 0 hours. Or when we started, right? When we started looking at our population. So this is when we started, right? That's at 0 time. That's how much we started with. And the last one says, okay, but now H is -3. So what does it mean for H is -3? That means what? How many hours ago? 3 hours ago. Here's how we're going to do our work. You're going to write it as 1,000 times 2 to the negative 3. Negative exponent means what word? Negative exponent, everybody means reciprocal. That's everybody. Negative exponent means reciprocal. So we're going to have 1,000 times 2 to the 1 over 2 to the third, which is actually 1,000 times 1/8, which means you're taking 1,000 on your calculator, right, and dividing it by 8. How many bacteria was there 3 hours before they started this experiment? Like how much prior to that? 125. So when you take 1,000, now if you're putting this in your calculator, can you put this whole thing in your calculator like this? 1,000 times 2 and raise it to the negative. You can put it into the negative exponent. But my hint would be, as we're doing these, getting used to doing that reciprocal part. So this is 125, which is 125 bacteria, right? And we're talking about 125 bacteria 3 hours before this began, right? So let's look at your workbook at C3. Now, it's a lot like C2 and it's just the one page. Okay? So, what I would keep open in your notes is this page right here of how we did this, because this is going to be really helpful. And this. So this is the top and bottom of that page in your notes. That's something to help you look at as you're trying to figure out how to do some of the questions, okay? When you get to C3, questions 1, 2, and 3 are kind of from that first video. You're just going to write down positive or negative. You don't have to tell me what it's equal to. You just got to write the word, I think this is going to be positive because of how it was, or negative. You're simplifying 5 to 16. What might I put number 5 over? Or number 6 over? 1. Anytime I have negative exponents, just to help me out to start the problem, I might put it over 1. 5 and 8, are they going to have the same answers? Turn to your workbook, gentlemen. You got to be on this page if you're helpful if you're with us. 5 and 8, do they have the same answer? They're both to the 0 power. Should they have the same answer? What do you think, Sam?
5 and 8?
Yeah?
Yeah.
You think yes. Emily and
Wait, no.
Herbert say no.
No.
Why?
Because one's a negative and one's a
One
positive.
has a negative in front of it, even though they've got that 0 power. Let's look at number 7 together. Number 7. This seems to give people problems. I'm going to write it out like we did before in our notes. We're going to go 5 times 1 over 5 to the negative 2. And I just think this way of writing it helps to break down the problem. So when we look at this, which one do we need to move? Where's our negative exponent? This negative 2, right? So we have to move this one up, right? So the first one stays the same. 5 over 1. Nothing changed, right? That stays the same. Times, I'm now going to put 5 to the second over 1. 5 to the first times 5 to the second, that's 5 times 25 gives us 125. Right? Look at number 13. Do you guys know what 8 divided by 4 is? 2. I'm amazed as we do this that people will go, you can't do that. You can't simplify with variables in the exponents. This is just 8 divided by 4, which is 2 over 1, right? That's what that answer is. And then you have m to the negative 2 over 1 times 1 over n to the negative 4. Negative 1, is it? 1. So now, which ones would we be moving? you were gonna circle them, Nathaniel, what would you circle that needs to move? What are my negative ones? Do I move the 2? No. This is gonna move down, right? And this one's gonna move up to get my final answer, okay? I would do the same thing with most of these problems, okay? So number 17 is the one that's that story problem. They're asking you to use D to the 2, talking about the population, okay? So it's just this side of the worksheet that is due for tomorrow. Question.